Skills of the future in the marine industry: what will last, what will evolve, and what to learn by 2030. The maritime world is on the edge of a transformation. From zero-emission propulsion to AI-powered autonomy, the marine industry is undergoing a shift unlike any in its history. As climate regulations tighten, ports digitize, and autonomous craft hit the water, one question becomes clear. What technical skills will be needed in this future, and which are at risk of being replaced by artificial intelligence and automation? For maritime professionals, engineers, students, and decision-makers, the path forward will demand a new kind of skill set, one that combines deep technical knowledge with adaptability, innovation, and cross-disciplinary thinking. The nature of hard skills in the maritime sector. Hard skills are the technical, often industry-specific abilities that are taught through study and practice. In the marine context, these include naval architecture, propulsion system design, electrical integration and marine electronics, CFD and hydrodynamic analysis, route optimization and navigation systems, data acquisition and interpretation, ship system automation, marine cybersecurity. These skills are the backbone of maritime operations, shipbuilding, offshore engineering, and vessel design. They're what keep fleets moving, ports operating, and innovations like hydrofoils and sea gliders flying just above the water's surface. But in a world where AI is becoming smarter and automation more capable, how secure are these skill sets? Will AI and automation replace maritime hard skills? In certain areas, the answer is partially yes. Many repetitive, data-heavy, or rules-based tasks in ship design, routing, and diagnostics are already being handed off to algorithms. For example, AI-based route planning is improving voyage efficiency, reducing fuel use, and cutting human workload. Autonomous navigation systems can now steer, dock, and monitor vessels in real time with minimal intervention. Digital twins of ships can simulate performance in different sea states, reducing the time spent on physical prototyping. However, the story doesn't end there. While AI is changing the nature of technical work, it is not eliminating the need for skilled marine professionals. Instead, it is elevating the role of human expertise, making it more important than ever to understand the system, manage risk, and apply judgment in real-world environments. Just as a ship's autopilot doesn't replace the captain, AI does not replace the marine engineer, it amplifies their decisions. What hard skills will matter most in the marine industry by 2030? Over the next 6 years, the most valuable hard skills will be those that work with AI, not against it. Support sustainable maritime operations. Bridge disciplines like hydrodynamics, electrification, and autonomy. Are difficult to automate or replicate without context and experience. Here are 6 future-proof hard skill categories tailored to the marine world. Marine systems integration and electrification. As the industry shifts toward hybrid and fully electric vessels, professionals who can design, test, and integrate electric propulsion systems will be essential. This includes knowledge of high-voltage battery systems, thermal management, electric motors and drives, hybrid diesel-electric configurations, maritime grid integration and shore power, cold ironing, simulation, hydrodynamics, and digital twin engineering. Simulating vessel performance in real-time environments. Wind, wave, current is becoming core to vessel development and operations. Skills in CFD, computational fluid dynamics, Simulink, MATLAB, and model-based design. Real-time simulation, hardware in the loop. Creating and validating digital twins are critical in both design and onboard diagnostics for next-generation craft. Autonomous and remote operations. With uncrewed vessels emerging in offshore, survey, and coastal transport, autonomy engineers with marine experience are in high demand. Hard skills include sensor fusion and navigation systems, GNSS, radar, LiDAR, AI-based motion planning and guidance. ROS, Robot Operating System. Fail-safe control system design. Hardware-software integration across marine environments. Maritime data and decision support systems. From condition-based maintenance to fleet optimization, the ability to manage and apply maritime data is now a key technical skill. Professionals will benefit from knowledge of marine IoT and telemetry, data analytics and signal processing, machine learning applied to vessel monitoring, real-time dashboarding for port and ship management, cybersecurity in critical maritime infrastructure, autonomous systems, port networks, and electronic navigation all present growing cybersecurity threats. In response, hard skills in network defense for vessel and shore-based systems, secure communication protocols, example NMEA 2000, IEC 61162. Penetration testing of autonomous platforms. Regulatory knowledge, IMO, IACS, NIS2 directive, are fast becoming essential for shipyards, operators, and technology providers. Sustainable design, life cycle engineering and compliance. With pressure to decarbonize, new builds and retrofits must be sustainable from design to decommissioning. Hard skills here include life cycle assessment, LCA, emissions modeling and reduction strategies, design for recyclability and material efficiency, compliance with IMO GHG strategy, EEXI, CII, and EU ETS, understanding of hydrogen, ammonia, and battery safety systems. What should aspiring marine professionals study? Whether entering university, mid-career, or transitioning into maritime tech, these disciplines provide a strong foundation for the future. Marine engineering, naval architecture, mechatronics with a marine focus, systems engineering, autonomous systems or robotics, data science or cybersecurity with maritime applications, sustainable energy or environmental systems. Supplemental certifications will also be critical. MATLAB/Simulink, Rhino/Orca 3D, or Star CCM Plus for modeling. ROS or PX4 for autonomy development. ISO 27001 and IMO cybersecurity standards. Project management for complex marine systems, Prince 2, PMP. Most importantly, real-world exposure from sea trials to simulator labs will help learners apply theory in dynamic, high-stakes environments. What AI can't do in the marine world. AI may power the next wave of maritime automation, but it still lacks one thing: human context. It cannot judge the political impact of a port shutdown. It doesn't weigh ethical trade-offs in crew safety versus cost. It cannot innovate outside the data it's been given. That's where human expertise, technical, ethical, and operational, remains essential. The hard skills of tomorrow are not just technical, they are contextual, creative, and collaborative. Final message. Hard skills in the marine industry are not disappearing, they're transforming. From shipyards to sea trials, from bridge systems to back-end code, the professionals of the next decade will be those who embrace intelligent systems, understand sustainability, think across disciplines, and adapt to change, fast. For those ready to learn, lead, and evolve, the marine sector has never been more exciting or more vital to the future. Because when the world changes, the ones who stay afloat are the ones who learn how to navigate.